Hi guys, today we're talking about 2.1 complex numbers. I'm going to focus on objectives 3, 4, and 5 from this lesson. Dividing complex numbers, performing operations with square roots of negative numbers, and solving quadratic equations with complex or imaginary solutions. If you have questions on objectives 1 and 2, still listen in because I'm going to address those. I'm just not going to do this checkpoint specific to those objectives, okay? I think with what I say and what you see in the textbook, you should be able to do those objectives on your own. If not, definitely ask a question about it in class. Okay, so let's get started. Objective 3, dividing complex numbers. Checkpoint 3 went with this objective. And we're dividing and expressing the result in standard form. So I'm going to talk to you about how to divide, some important vocabulary, and what standard form looks like. And we'll get there here in a little bit. Okay, so when we look at this, how do we even know this is a complex number? A complex number is made up of a real part and an imaginary part. So the real part of this numerator, this complex number, is 5 plus 4i. 5 is the real part, 4 is the imaginary part. In the denominator, 4 minus I is another complex number. 4 is the real, and -1 is actually the imaginary. The I, we're going to treat it as a variable. It's really a unit, and it represents that we've taken the square root of -1. Okay, so if you remember how to what we called rationalize a denominator, and this was back in chapter P. We talked about rationalizing denominators. It's not okay to have square roots in a denominator. And so we had a strategy that allowed us to get those out. And then we're going to use that same strategy here when we divide complex numbers. The 4 plus I. Notice that it came from the denominator. We had 4 minus I, and we're multiplying the denominator by 4 plus I. That's going to accomplish a couple things for us that I'm going to show you in a minute. We must also multiply the numerator by the same 4 plus I, and that keeps our value the same. It keeps our fraction balanced. We've just really multiplied by 1. It's just a really fancy version of 1. The 4 plus I, remember, that's called the conjugate. That's when we take a binomial and we change it from a sum to a difference or a difference to a sum. Okay, so now we're going to get on with actually multiplying these together. So this is hitting objective 2 in lesson 2.1. Okay, so looking at the numerator, we're going to have to FOIL that numerator. We're multiplying two binomials. If you would rather think distribution, that's fine. We're going to get 20 plus 5i plus 16i plus 4i squared. I've highlighted the I squared in blue. I want you to remember that I squared actually has a value of -1. And I did not write that down, so I'm going to do that right now. I squared equals -1. Okay. So we are going to use that substitute in here. And that gives us 20 plus 21i plus -4. Okay, the denominator we're going to FOIL as well. In the denominator, we're going to have 16 plus 4i minus 4i minus I squared. So if you multiply by the conjugate, those two, the plus 4i minus 4i, your OI terms should always cancel each other out. Once you get really good at multiplying in this way, 4 minus I, 4 plus I, a lot of mathematicians don't even put the plus 4i minus 4i knowing that it's going to cancel. And then the minus I squared is really like subtracting -1. We need to replace that. Part of standard form of a complex number is that we have only a real part and an imaginary part. The imaginary part has an I, never an I squared. So when we see I squared, we always replace that with a -1. Okay, let's clean this up just a little bit more. we have 16 plus 21i all over 17. And remember, that means we're actually dividing the 16 by 17 and the 21 by 17. So 16/17 plus 21/17 I is the standard form of a complex number. If we were to try to leave it here, we would actually be taking a complex number and dividing it by 17. The standard form requires us to actually show the real part as 16/17 and the imaginary part as 21/17. Okay, let's go on to example 4. Objective 4, example 4, checkpoint 4. They don't always go together like that. We'll see that in this chapter. Know that you can pause this at any time. You can go back and listen to it again. It will be here our entire year if for some reason you needed to come back and get it. Okay, so 2.1 objective 4. Perform operations with square roots of negative numbers. Perform the indicated operations and write the result in standard form. Again, that's that A plus BI format. All right, so we see -2 plus the square root of -3 squared. This is part B on checkpoint 4. If I do this with part B, you should be able to do part A, and part C you should be able to get as well. Okay, the big deal with this is to not get carried away and square this right off the bat. What you want to do instead is to rewrite the square root of -3 as I radical 3 first. Otherwise, the imaginary value that's really going on here with the square root of -3, it's going to get masked and it's going to get covered up, and it will affect your answer in a negative way. Okay, so the first thing I did was square root of -3, changed it to I radical 3. Now let's consider the square. Remember, it's when you have a binomial, it's not just square the first, square the last, but we have to FOIL. So it helps to write it out as the binomial times itself. And then we can go on with FOILing, just like we did in the dividing problem with objective 3. Okay, so we have +4 minus 2i radical 3 minus 2i radical 3. Notice that when you square, the OI terms do not cancel each other out. In fact, they double every time. The OIs will match, and so when you bring them together, it's twice what the inner was or twice what the outer was. And then we have plus I squared times 3. If you take I times I, that's where we get I squared, and the square root of 3 times the square root of 3 is 3. You might want to go square root 9 and then say that that's 3. Okay, so we're going to fix a couple things and we'll be done with this one. 4 minus 4i radical 3 and then plus -3. The -3 comes from -1 times 3. And so 1 minus 4i radical 3. We really do want to write it in this way with the real first, the 1, and the imaginary second, the 4 radical 3. And that's to keep it in that A plus BI standard form. Okay, last one we're going through. Solve quadratic equations with complex or imaginary solutions. And this says specifically solve with the quadratic formula. If we're going to get complex or imaginary solutions, we're not going to be able to solve that with factoring. Our options are going to be quadratic formula or completing the square. So, quadratic formula, let's remember what that is. Make sure you're putting x equals. Don't just throw the -b. Don't get too excited with that. You have to say x equals -b plus minus and go on with that. All right, so I have filled in the A, the B, and the C. And then don't just go substituting this into your calculator. You want to simplify. What we're going to do is simplify each of the 3 parts. And here are the 3 parts. The negative version of B, the discriminant, which is the b squared minus 4ac, and the all over 2a. We're going to simplify those separately. Make sure if you're plugging the discriminant into your calculator that you say -2 in parentheses. If you do not put it in parentheses, your calculator, most calculators misunderstand you. You're not telling it to square the negative if you don't put the -2 in parentheses with the square on the outside, just as I've written it. Okay, so -2 is 2. Plus minus, the discriminant value is -4 all over 2a, which was 2. So we see this, the square root of -4. That's where the complex or imaginary solutions are coming in. If your discriminant is negative, you know that you have complex or imaginary solutions. We're going to talk about the graph here in just a second as a little more for your money today. Okay, so the square root of -4 is 2i. So we have 2 plus 2i all over 2, and we want to make sure that we divide each of these parts by 2. So 2 over 2, 1, plus minus 2i over 2, 1i. Okay, I want to also show you what implications this has for our graph. Let's go to the next page for that. All right, what do the complex solutions tell us about the graph? Okay, well, one of those things is solutions on a graph are normally our x-intercepts. And if we have complex solutions, that means we're not going to have any x-intercepts. But there's one other thing it also shows us. It also shows us the axis of symmetry. So we shouldn't be surprised about where this graph shows up. The axis of symmetry is actually the real part of your complex solution. So if the complex solution 1 plus minus I, the axis of symmetry is that line x equals 1, that vertical line through the x-axis at 1. Okay, so here is a graph of y equals x squared minus 2x plus 2. I put in the x equals 1 to show you that that axis of symmetry worked out, and the graph is confirming for us that this equation never gives us a y value of 0, and that would mean it never has an x-intercept.